Yes. All right. Dank u om mij uit te nodigen. Koen. Ik wil vandaag een klein beetje... English. I'm going to talk a little bit about connecting Flutter apps with IoT devices. Normally, I was going to be here together with Johanna because she's our one of our Flutter developers. Sadly enough, she has corona, so she had to cancel. So that's why I'm here alone. Otherwise, it would be her presenting. I'm the co-founder of Altra. What we do at Altra is connecting humans with machines. And that's something that we've been doing from 2008 until now. From smart home systems to heat pumps, just to give you a little bit of context what our company does. But there are a lot of discussions about what is IoT. So I want that to be clear. IoT is a machine that has some sensors, and those sensors measure things. And then those sensors send data. They are processed on the machine or not. They communicate that data to the internet, for instance. And then you gain some insights. You show some analytics. You show some visuals. And the whole process of connecting that machine to the internet, that is IoT. That's our definition of what is IoT. But if you want it very practical, you can think of smart things. And that can be smart city applications, although the electricity meter is not really smart. But there are smart traffic lights, so everything that is around the smart cities. You have smart home devices. Could be a temperature sensor, could be anything from lights until blinds or heating. Wearables as well. That's actually a booming market. Everything that is medical is becoming more and more smart. This is an insulin meter, but also smart industrial equipment. Can be air sensors or other industrial equipment that is installed in order to improve the industrial process. There are three main ways to connect such a sensor to an app. And why is that? Because the smartphones only have two main communication channels, and that is Bluetooth or Wi-Fi. And if you have a machine that connects to the internet, everything that happens before could be different protocols. So there are multiple protocols that hardware can communicate with, but they all connect to some sort of gateway or to an internet server, and then you can connect to that server in order to control that device. The other one is Bluetooth or BLE. Those are two different things, to be clear. You can directly communicate to a device using Bluetooth, because that's also some communication technology that you have in your smart home, in your smart phone. And then you have direct Wi-Fi, using the Wi-Fi technology to connect directly to a device instead of Bluetooth. So if you talk about a lot of protocols that you have for IoT, like LoRa, Sigfox, Zigbee, Z-Wave, and there are a ton of others, they all connect to a gateway or a server. The advantage is that you can control that device from anywhere in the world, as long as you have an internet connection. The disadvantage is that you need an internet connection. So it could add some extra delay to your app compared to a direct communication channel. Technologies that you can use, in this case of IoT, are WebSockets, a REST API, or, and that's the most common one today, an MQTT client. How do you use MQTT in Flutter? There are not a lot of packages, but yeah, the most easy one to use is the MQTT client that you can install. MQTT is a protocol. If you know WebSockets in general, it's basically a WebSocket that connects from your Flutter app to a server, and you have some topics where you can subscribe to. So instead of getting all the data of the whole device every time that something updates, you say, okay, I want to subscribe to one certain topic. So in order to connect to that server, you just have to add the server address. It usually authenticates with a client identifier, so it knows which client actually connects. And then you can just connect to that server. As soon as you have the connection, you can say, okay, to which topic do I want to subscribe? And it can be one, it can be multiple, depending on what you want to show in your app. But it gives the advantage that if you switch screens, for instance, you don't have to subscribe to each topic every time. You only subscribe to that piece of data that you actually want to show in Flutter. So for instance, this example subscribes to the temperature of the bike, and it listens to it. So it opens a socket, and as soon as the temperature is published from the bike, it could be when it's different, it could be on a regular interval, depending on the device itself. And as soon as you get it, you do something with it in Flutter. I'm not going into how to visualize it, because that's something I expect you to know. And then sending the message, so that's from the device to your app. You can also communicate back, and that's publishing a message. And depending on the device, it could be that you just send a string, it could be byte data, depending on what the device can actually handle. But this is a very simple example of a message that you just send to the device, and the device can display it. So it's a string that is being transformed and then sent onto that topic. The bike also has a MQTT connection, and then instantly receives it and can do or handle something with that. So this way, with only a couple of lines of code, you can actually control a device already. But it needs to be MQTT compatible, of course. Another way to connect is Bluetooth. You have two different types of Bluetooth. You have the classic one. It uses a lot more energy, but you have a very big bandwidth. And then you have BLE. If you are using devices in general, usually BLE is the technology that is being used, because it has a lot less power drain from the device itself. So if it has a battery, it actually lasts a lot longer, and you can easily connect to it. There are two main libraries that you can use with Flutter. That is Flutter Blue Plus. It originates from Flutter Blue, which is a very old library. You really don't want to use that one. So if you want to use Flutter Blue, then Flutter Blue Plus is the one that you actually want to update to. And then you have Flutter Reactive, BLE, that is actually developed by the Philips Hue team. So it also has a lot of support. They are quite equal in terms of issues and commits, and so those are the two that I would recommend to use. Those libraries, they can scan for a device, they can create a connection to the device, they can read and write characteristics, they can observe the status of the host, whether it's connected or not, and you can also subscribe to characteristics. So just like with MQTT, where MQTT uses topics, Bluetooth uses services and characteristics. So each communication technology has their own terms in how to read the data. But of course, if you want to start using Bluetooth, then you first have to check whether Bluetooth is enabled or not on your device, because that's a very common mistake to forget, because if you just try to connect and to scan, then everything fails, your app can crash, and so first check whether it's enabled or not, and then you can show a nice message. You can also use it to enable it and to allow it, but it's done in a very easy way anyway. And then connecting to a device, so you need to scan for a certain device that is within range. So how can you do that? You can just scan all the possible Bluetooth devices that are advertising in your neighborhood. You can filter based on the name, but you can also filter on the ID of the device, but also the services of the device. And then as soon as you found the right device, you can also show that to your user, of course. If you have a certain list of devices, and you can say, okay, select the right device, and then you connect to the right one. As soon as you are connected, you can start subscribing to a service. How does Bluetooth work with services? There's a whole library of service UIDs. That means that there's an instance, and that's the link that you can subscribe to. There's a whole document, I think it's almost over 100 pages, with all different services that can be used by Bluetooth. And that range is from reading a battery, to reading heart rate, to anything that you are used to within the Bluetooth devices. They're all fixed, but they allow you to also create your own Bluetooth service if you're actually developing on the device side as well. But if you're interested in developing yourself an app to connect to a heart rate sensor, for instance, then you can look up in that table, okay, which service UIDs should I use in order to connect to it. But of course, if you're building your device yourself, you have to avoid to use one of those IDs, because then you could be in conflict, and you might have a problem if other apps try to connect to your device. This is quite technical, but two examples of a battery service UID, and within a service you can have characteristics. It's like subscribing to a certain device, and then within that device you have the temperature, the humidity, stuff like that. But it all depends on which type of device that you want to connect to. A device can have one or more services. I have seen examples in the field where for each characteristic they made a service. Oop, that's not okay. So for each characteristic they made a service, but know that you only can have 24 services, something like that. There's a limit on that, and then you're stuck. So try to avoid using a service for each characteristic. Try to group them in a very logical way, and ideally use the lists as a starting point. But coming back to Flutter, if you know to which service you want to subscribe to, and if you know to which characteristic you want, which characteristic you want to read and or write, you can actually search for that within the device that you are connected to, what I showed earlier, and then filter out the right characteristic, and then you're good to go. Then you can read it. By reading it, always take in mind that it could fail, definitely with Bluetooth. Try to have a lot of error handling if it times out, if it fails, stuff like that. And then you can read the actual property, return it, and continue with it, show it in the app. Writing the characteristic is very similar. You make the properties that you want to send, and then you convert it into bytes and you send it to the device. In this document, you can also find how the properties or the characteristics are actually formatted in bytes and how you should transform from an integer into bytes and how the precision is taken care of. That's all described there if you actually want to start coding tonight. Right now I showed you how to connect to a Bluetooth device, but that's non-encrypted. So that's just connecting to the device. You can read and write. If there's a man in the middle, they can read everything that you send, and they can read everything that you actually read from the device, which is not secure. So in a lot of cases, you actually want to secure the connection between your app and the device itself. The way that you do that is to pair a device. That's something that you are most likely familiar with. It's as soon as you want to connect the device on your mobile phone, you get a PIN code on your screen, you get a PIN code, for instance, on your car, and you actually have to prove that you pair your device to your smartphone to the device itself. As soon as that PIN code is exchanged, then all traffic between your app and the device is secure. But there's a difference between pairing and bonding. So pairing is a one-time security measure that you make, and you exchange some keys in order to encrypt the communication. If you want to save that connection for later usage, so next time you start up your app, you actually want to start communicating immediately without exchanging the PIN codes, you actually want to create a bond. And then this is the way that you create a bond. You can see that it's all fairly easy if you know the different steps of how to connect to that device. But in Flutter, the packages are actually quite stable right now, and you can actually depend on it on Android and iOS. And then we have a little demo time. So, yep. So normally, yes, you see my iPhone. And then we have the Spectre bike here. So this is an Android system running on the bike itself. Yeah, I'm gonna unlock it. Yep. And I'm gonna put it into pairing mode. So right now the device is advertising that it is ready to pair. So if I have the Spectre app that connects to the bike using MQTT right now, so you can see that on top it's connected via 4G, so it can read the data from the bike. But if I want a direct connection, I can start the pairing process. And as soon as I scan the device, so that's scanning the different Bluetooth devices based on the service ID, and it also advertises the serial number. So the app filters out to which bikes you actually can pair to. If you have 4 or 5 different bikes here, you all put them in pairing mode, you will only see the right bike based on that Bluetooth protocol. So it filters out the right serial number, and then as soon, okay, this is, yes, okay. So I think I just waited a little bit too long. So if I want to pair now, it actually will try to make a connection to it. So it shows a message on the phone with the PIN code, and it shows a message on the bike with a PIN code, and now the pairing is made, and we also create the bond. So the bike is actually connected to the app. Now you see on the top right that it's connected using Bluetooth, and then when I can lock the bike, yeah, you don't see the lights immediately because it has some delay on the lights. but the screen is blank. Yeah, you see that the lights are locked now. And since we have a direct Bluetooth connection, as soon as I press the button, it actually unlocks and you can start driving. So that's a little demo of what I showed you, what is happening behind the scenes. And then the last way that you can connect to, wait, I'm just gonna prepare for later. Yes, okay. So another way that you can actually communicate to an IoT device is Wi-Fi. So of course, if you have the first scenario where the device connects to the internet and you uses MQTT, then it also uses Wi-Fi. But what if there's no internet available? In this case, the device that you see there is electronics for a gate. But those gates can be installed in France. And in France, the 4G coverage is really bad. And when they are installed, those gates, there's no Wi-Fi, there's no internet, because that's actually when they're building the house. So in that case, we needed to make a direct connection to the gate in order to configure it and to program it. And using Wi-Fi, we can trigger the gate to make itself as a Wi-Fi hotspot, which means that it sends out a fixed Wi-Fi name, an SSID, and it has a fixed password that you can connect to. You most likely saw that already if you're installing any device at home, then it says, yeah, try to connect to this Wi-Fi, go to this IP address, and that's a very a big hassle for users actually, because they have to read the manual, they have to know, okay, to which IP address should I connect, what is the password, and that's where we used Flutter in order to streamline that whole experience. But as soon as the app actually connects to that Wi-Fi hotspot, it gets an IP address from the device itself and it can communicate. The way that you can communicate at that point, that could be a REST API, that could be MQTT, that's all dependent on how the web server on the device is actually programmed. What you could do until iOS 10, that's a long time ago, was scanning for Wi-Fi networks. You can still do that on Android, but Apple decided to shut down that feature because of privacy reasons. What Google did was scanning the whole world, actually, of Wi-Fi MAC addresses. They made a whole database out of it. And right now, if you have 2 MAC addresses and their signal strength, Google can actually locate you within 2 meters where you are, based on that. Apple saw that, and they said, okay, we're not going to allow to do those things on iOS. So if you want to use direct connection to a device, you could either ask for entitlements at Apple, but that means you have to motivate why you actually want to do that. You have to prove that you're not going to misuse it, blah, blah, blah. You have a very big procedure, and the chance that you're getting approved is very slim. So the best way is to have a fixed Wi-Fi ID and a password in order to connect. If you do want to scan, then Wi-Fi scan is actually an OK library to do that, and it shows you the different Wi-Fi network addresses, and that works on Android, but it doesn't work on iOS. And Wi-Fi packages, there's a lot of permission, because of those privacy issues, there's a lot of permission problems with Wi-Fi. So we tried a lot of different packages that actually talks with Wi-Fi, but the best one is Wi-Fi IoT, but we decided not to go for using the package, but writing the actual Wi-Fi code native. And I think that's the strength of Flutter as well. As soon as you notice that packages aren't up to date or have too many features in order to for you to use in the app, that you actually always go to a native part and communicate between those two parts. So on iOS, this is the lines of code in order to connect to the Wi-Fi network. And that means you have the hotspot configuration, you give the SSID, you give the password, and you let iOS connect to that Wi-Fi network. And as soon as we get some response from the iOS code, then we actually send it towards Flutter in order to continue within the app and to continue with the UI. And the same code that we have for Android does exactly the same, enters the Wi-Fi SSID and password. What happens in the demo that I will give very soon is, as soon as we have a connection to the device, we update the firmware. So we have the scenario that we don't have any internet, and we added the firmware of the device in the Flutter app itself. So as soon as we have the connection to the device, we grab the firmware, we send it towards the device, and that way it's always up to date. So when the installer updates the app from the App Store, goes on location, connects to the device, it first will update the firmware, it's up to date, and they can continue with the latest version. And then the web page, so the IP address that the installer had to enter themselves, we just open the web page and we navigate to that within the app without the installer actually having to notice that they have to switch apps. So that way the user experience for that installer is just downloading the app from the App Store, opening the app, connecting to the device, it will update automatically, and then it will show the web page so they can do the configuration. And I think that's the power of Flutter, that you can combine web technology, native technology, and the Flutter all in one app, in a very good user experience. And then of course that web page, what it does as well is send some messages back that we can capture from the web page in order to adapt the UI and show a next button and all that. So it can be used directly onto the device if you want that, but that way you have an interaction between the app and the web pages themselves. And then we have some demo time again. Yes. So the installer sees the setup. So as soon as they say, okay, I want to connect to the Wi-Fi, it's already connected. So it detected that it will update the firmware. It will update the firmware now. So it's sending that binary package using a normal post command to the web server of that device. And then we added some timer because the device needs to restart and you need to reconnect to the device. So that's a fixed timer to give it time to be up and running again. So the Wi-Fi hotspot is available. So we're waiting for that. Come on. Yes, that's the Murphy demo. Murphy. Just gonna check. Yeah, it's still connected. Okay, then I'm gonna try again. Okay, it will join. Yeah. I know that's a risk that you take when giving demos, but since we're all developers, I know everyone can feel the pain of demo time.
Maybe I have already a question. Did you open source the Wi-Fi Connect package already? Maybe.
No, not yet.
Is that something that you will be doing?
Everything that we do for clients, we can't open source.
Okay.
But that doesn't mean that we can't make our own package based on the experience that we have.
Mm-hmm.
But I think it's a good suggestion, so I will take it up with... come on. Okay, I will take it up with Johanna, and I'm pretty sure that she will want to do that. Okay, so now it's updating again.
Maybe another question.
Yes.
Do you have concurrent connections then with the Wi-Fi direct to the device and to the internet? Or
No.
are you using 4G or how is, because it's getting an IP address from the device?
Yes.
The Wi-Fi direct?
Yeah.
So how is it connected to the internet to know if firmware needs to be updated or?
That's built in the Flutter app. So it's Flutter that decides whether it needs to be updated or not, and the firmware is in Flutter app itself.
And then when you go to the web view that you were talking about, that's connected to the internet again. So
no, that's on the motor itself.
also,
So
okay.
then
So it's hosted by the device.
it's hosted by the device, yeah. Because we needed to be offline compliant, of course. And also we did different projects where we connected directly to a device and wanted internet connection at the same time. That's a very big hassle on iOS. On Android, that's not a problem, but on iOS, that's a very big problem. Okay, so as you see, as soon as you want to do something with Wi-Fi and also Bluetooth, you need a lot of error handling. Because if you don't have good error handling, then your user is completely blocked. So I'm gonna try one more time, and if it doesn't work, then I'm just gonna skip it. Yes. But if you have any other questions while we are waiting, yeah.
So you also developed the firmware for that device?
No. So we start from the device itself, and then it's restarting the motor. Yeah. So we work with different partners that actually create the firmware. Yeah. And then we communicate and we decide together. Yes, okay, so now it tries to join again, but yes, okay, yeah, and now you see the web page that is loaded. So the bottom part, this part is Flutter, the rest is the web page itself, and then they can actually choose a certain configuration. Of course, it's quite technical for the installer, but as you see, the bottom part disappears as soon as you go in a certain item, so they can actually be guided the right way, and then they can save and continue the configuration, and then it's done. So it's a small configuration app, but Flutter is actually helping here in order to be cross-platform and to have the firmware update and stuff like that. And then the elephant in the room, if you talk about IoT, Matter. There's no implementation of Matter for Flutter anywhere. There's one package, but it has 0 lines of code and some demo documentation, so I don't think it's usable. But what is Matter? Matter is a new protocol that is based on Wi-Fi and on Bluetooth. It will use Bluetooth to commission a new device within your smart home, and it will most likely use Wi-Fi in order to get an IP and communicate with the other devices. It could also use Bluetooth in order to create a mesh. That's done with Bluetooth 5.0. The idea of Matter is that you don't need to make an app for each device. So if you have 10 different apps right now to control your lights, your blinds, your temperature, the goal of Matter is to centralize that in the main platforms, and that's the Google Home and the Apple HomeKit. But I'm pretty sure that configuration, maintenance, support, and all that, you still need an app for that. So the daily controlling of the device, that can be done using Google Home, but installing it and making sure that you have the right scenes and stuff, that is something that still will need an app. And Matter is very slow, so they thought that the growth would be a lot quicker, but it's not as fast as they predicted. So I think that it will be mainstream in 2, maybe 3 years. I don't know, Peter, if you have a different view on that. But yeah, it's something that will come the coming years. So my conclusion is that I think Flutter suits making an app for IoT very good. It's very flexible, and it's not that if you don't find it within the Flutter community or in the Flutter publications that you can't solve a problem. So I think that's very important for a platform to be open, to be supportive as much as possible. And the BLE support is quite good. So if you would have asked me 2 or 3 years ago, then I would have said maybe not, but today, yes, you can use BLE with Flutter. Wi-Fi, not really. There's some packages, but due to all the different privacy rules of the OS, it's just almost impossible to make one universal package for Wi-Fi. So that's it for today, and I hope I taught a little bit. If you have any more questions, don't hesitate to ask. Yes?
You were talking about 2 packages that did Bluetooth support. Are they both compatible with BLE and Bluetooth?
Yes. Yeah. Anyone? Yeah?
I have a question, which I just forgot. That's right. You were talking about something about having special permission to be able to use the Wi-Fi scanning.
Yeah, on iOS.
Yeah, I noticed that for iOS in the App Store, I was using NFC, for example. So the NFC near-field communication for activating a device. And I had the same problem. I had to send a video of myself using the app in the application.
Yeah.
Which was odd. To Apple.
We always have to do that. With every app that we submit, we have to make a video of how we actually use it.
That's because I think because of the IoT part. So
yeah.
I was going to ask you that question. Do you have to do that as well when you're using BLE support or something like that?
Yes.
I haven't published any BLE apps, but I have published an NFC app, and I have to go through that process.
Yeah.
So
as soon as there's a component that Apple can't test, they want to see proof that it actually works. So you have to, usually it's 2 or 3 rounds of revision, but as soon as you submitted the first version of the app, then they most likely don't ask it again in the revisions afterwards, but yeah, it's very random.
Okay.
Yeah.
I'm not the only one. So
No. Yeah.
Did you actually need to be in the video? Because we also have...
No, I had to have the app running in the video, so someone was videoing me using the app, but just the app in the video and an activation.
Because we only sent the screen recording and it was fine.
Yeah, I sent a screen recording, but they said they wanted to see it in action with the thing that I was interacting with.
If you want to do it the first time right, then take a video where you see the app, where you see the device, and that you show the whole process. But because I just said it's really random, some reviews actually accept the screen recording, and others demand a video of the device itself. So if you don't want to take any risk and don't want to do it twice, then try to make a full setup. Yeah. Yeah.
We're building an application for smart locks for smart bikes, and we've had an issue with Android that needs to connect as well over Bluetooth.
Yeah.
And the connection on Android takes sometimes up to 1.5 minutes to connect. Did you have any issues with that as well?
Of course. Android is the worst than Bluetooth.
And on iOS it's just a couple of seconds, maybe half a second, and it's connected.
Yeah. It usually means that I'm going a little bit too much in detail, I think, but you have the Bluetooth GATT cache on Android. If you want usually the first time it goes really fast,
Yeah,
and the second time it goes really slow.
Yeah.
If you want, if you want to avoid that, clearing the cache, turning off Bluetooth, turning it on again. In the background, it can be really fast. Users don't notice that. Then trying to connect again usually solves the problem.
Because we need to discover surrounding devices to make sure, oh, okay, on this location, these logs are here, and we need to send them to the API as well.
Yeah.
Would that also work if we cleared the cache, and would that lose the different discovered devices, or?
If you discovered them and they are not in range, then you lose those that data.
So that's something that we need to implement in our own logic.
Yeah, if you just save those addresses yourself, and you build up your database, then I think you're good to go.
Yeah, okay.
You can't rely on the cache of Android.
No.
No.
Yep, thanks.
Okay.
That's all we use.
Thank you very much.